Hello everyone, my name is Neha Kadam, and in this lecture we are going to learn about arithmetic circuits. This lecture is the second part of arithmetic circuits, and in this we will be covering binary subtraction, half and full subtractors. So these two topics we will cover in this lecture. So let's begin with binary subtraction. So this is an example of a binary subtraction. We have 1011 and 101. We want to subtract 101 from this binary number. So let's do it. So when you subtract 1 from 1, then it's going to be 0. And if you subtract 0 from 1, then it's going to be 1. Now here you have 1 here and then 0 over here. So we need to borrow some number from the left to here, and that will make this number as 2, and then when you subtract you will get some number over here. So let's see. So this will be 0, borrow is taken, and now this is 10, which is 2, and 10 is your 2 in decimal, and if you subtract 1, then you are going to get 1. So that's what you got. Okay, now and then this is 0, so you'll have 0 here. So you have 0, 1, 1, 0 is your answer. Now in this example we want to subtract 1, 0, 1, 0 1 from 1010. So here we have 0 here and then 1 here. So we need to borrow a number from the left, and that number will make this number as 2. So 1 minus 2 is 1. So borrow is taken here, and then you got 1 here. Now this is 0, this is 1. So what we are going to do, we are going to take the borrow from here, and that will go here and then further here. So let's see. So borrow is taken here, so this will be 0 and this will be 1, 0. And then when this is 2, 1, 0 is your 2, then we have to take one more, we have to take borrow from here, because the borrow has been taken just from here. So now it has been here. Now if you take from here, then here you will left with 0, 1, because this was 2, 1, 0 was 2. So you are now left with 0, 1, and then the other one will go here, and this will make this as 2. So 2 minus 1 is your 1, that's why you have 1 here, and then here you have just 0, 1. So 1 will come here, and then this will be your 0. So 0, 1, 1, 1 is your answer. And if you want to verify if your answer is correct, what you can do, you can convert the binary number into the decimal. So this is your 10 in decimal, and this is your 3 in decimal. So the answer should be 7 in decimal, because 10 minus 3 is your 7. So if you calculate this, if you convert this binary number, then this will come out to be 7. Now let's see the half subtractor. So this is the logic symbol of half subtractor. It has two inputs A and B, and the difference is going out, and a borrow, similar to what we saw in the adder. The only thing here, we are subtracting the two inputs. And this is the circuit for the half adder. So now if you compare this circuit with the this is the half subtractor, and now if you compare this circuit with the half adder, then you will see that we have just added a NOT gate over here. This is the only new gate, logic gate, which we have added into the circuit from the half adder. And so this is your XOR gate, and the difference is going out, and then this is your AND gate, and then a NOT is connected here. So at the output of this NOT gate you will get A bar here, and then B will go into this, and that will be your borrow. So you might be thinking how we got this circuit. So you get this circuit when you make the truth table. So truth table you will make the same way you did in the half adder. You will have like A and B as your two inputs, which will have 4 different combination, and then you have DI, which is your difference, which will find out the difference between those two numbers, and in the borrow you will put if there is any borrow in between A and B inputs. that will go in there, and then you will just look for ones, and then based on that you see corresponding inputs, and then you will create the circuit. So this thing we know this basics, and we have been making these circuits in the past, so you can easily create that. Now let's see some quick quiz questions. What is the difference and borrow outputs from this half subtractor circuit? So now you have A is equals to 0 and B is equals to 0. So if you subtract, so A is going in here and B is going in here, and complemented A is going into the AND gate, and then some part of the B input is also going into the XOR gate. So in this what will be the difference? The difference is going to be 0, because if you subtract A 0 minus 0, then the difference is 0 and there is no borrow. So the answer is this. Now if you have A is equals to 1 and B is equals to 0, then what will happen? When you have A is equals to 1 going in here and B is equals to 0. So in this case, the difference is going to be 1 and the borrow is going to be 0. You have to keep in mind this sign. So here A is 1, so which is greater, so that's why you have difference 1 and borrow is 0. Now what will happen, if you have A and B both are 1, then definitely the difference is going to be 0 and there will be no borrow. And then if you have A is equals to 0 and B is equals to 1, so now this is the case when we are going to have the borrow, because in this case A is smaller and B is greater, so 0 minus 1, if you have that, then in this case you are going to have a borrow. So we assume that so this A has taken up a borrow from the left, and that makes up this number as 2, which means 1 0. And if you subtract 1 from 1 0, then you will have 1 as a difference and 1 as a borrow. So you have difference is 1 and borrow is 1. So this was your half subtractor. Now we are going to see the full subtractor. So full subtractor is used for subtracting binary place values other than the ones place. So this is the full subtractor, and you can compare this with the full adder. This looks pretty similar. The only difference is that we have the borrow here. Now we have a borrow out and borrow in instead of carry in and carry out. And this is the logic diagram, which is made up from two half adder. And you can see that how borrow in going in, and this shows the difference. And then this is another half adder. Inputs are going into this and the output is going into this half adder, and the borrow is going into this OR gate. So borrow comes out from here, and this is the difference. So this circuit is your half subtractor, and then you can and then let's see the full circuit for the full subtractor in the next slide. Now here you see the full subtractor. This portion is your half subtractor and this portion is your half subtractor. So you can say that this full subtractor is made up of two half subtractor, and then you have this logic gate for the borrow. Now let's see what will happen if you have A minus B minus B in. B in is your borrow in. In this case we have three inputs, right? You have input B in, input A, and input B. So if you subtract these, and if you have B in, borrow in is going into the circuit is 0, and A and B both are 0. If all of these are 0, then difference is going to be 0 and borrow is going to be 0. So truth table from the textbook is very helpful to detect this. The answer is going to be 0 and borrow is going to be 0. So for this truth table, if you can refer to the truth table in the book also if you get confused, but this is not too difficult to understand that if you subtract all these, you'll get the difference 0 and borrow is going to be 0. And then what is the difference and borrow out output from a full subtractor circuit? You have A minus B minus B in, where B in is 1, A and B are 0. So 0 minus 1. So 0 minus 1, in that case you need to have a some borrow, and then only 1 can be subtracted from 0. So you will have a difference when you borrow, then you will have 2, and 2 minus 1 is 1. So difference is going to be 1 and borrow is going to be 1. So that's why you have here. Let's do for another case when you have b in is 1 and a and b are 1. So 1 minus 1 is 0. So 0 minus 1, again you have the same situation like previously, 0 minus 1. So you will again have the difference 1 and the borrow 1. And then in this case you have a is equals to 0, b is equals to 1. So b minus a minus b, which is 0 minus 1 is 0 minus 1 is your you have to take a borrow. So in that case you will have 2 here. So 2 minus 1 is 1. You will have 1 here. So 1 minus b in. B in is your 1, so it's going to be 0. So difference is actually going to be 0 and borrow is going to be 1 in this case. And then you have a minus b in, where b in is 0, a minus b. A is 1 and b is 0. So 1 minus 0 minus 0. So in that situation you will have one difference because 1 minus 0 minus 0, so you'll have difference 1, but there is no borrow. And then you have b in is equals to 0, a and b both are 1, so which means 1 minus 1 minus 0. So 1 minus 1 is 0, 0 minus 0 is 0. So your difference is going to be 0 and borrow is going to be 0. So this is how you basically form a truth table by putting all these different combination of inputs into the circuit and then find out what you get at the difference and at the borrow out. So I hope by this after this you can easily make up a truth table which will have 3 inputs, a, b and input b in, and there will be 2 outputs. 2 outputs will be difference and the borrow, and then you'll do the same combination. So for 3 inputs you will have like 8 combination, like 4 zeros, 4 ones, and then 2 zeros, 2 ones, and then 0 1, and so on till from 0 to 7. So 8 different combinations, and then you will have the same for the difference and borrow out, and this will come out based on the subtraction you do for this a minus b in. So this is the end of the lecture. Thank you so much for watching.